5 minutes in.
Okay, guys, I'm going to go ahead and teach you how to do negative and rational exponent complex fractions.
Yay!
It's really exciting. So first what I'm going to do is come over here and kind of just show you an example first for how to do this. So let's pretend that we've got 4 over x plus 3 squared plus 5 over x plus 3 to the, we'll say, third. All right, so Andrew, how would I go about getting a common denominator here? What would I need to give to this fraction?
I'm currently making a C in calculus right now.
So we're not going to ask him,
Yeah.
okay? So what I would do, if I want these denominators to be the same, I would need to add or multiply the top and the bottom of the left fraction by an x plus 3, okay? Because then if this is like a 1 as the exponent, 2 plus 1 would give me 3 of the x plus 3's in the bottom, and then these would match. So that's the exact same thing that we're going to do in this problem right here. Okay, so even though they've got fraction exponents and that looks kind of weird, you're still going to do the exact same thing. So the smaller of these exponents is 1/2. So I need to make that 1/2 become 3/2. And the way that I'm going to do that is by multiplying the top and the bottom by just one factor of 1 minus x plus 2. Or 1 minus 2x. Sorry. Alright, so when I put that in the top and the bottom, then what I'm going to do with these exponents is exactly what I would do over here. 2 plus 1 gave me 3, or would give me 3. I'm going to do 1/2 plus 1, and so 1/2 plus 1 is going to give me 3/2, because this 1 is kind of like a 2 over 2. So 1/2 plus 2/2 is 3/2. So then I'm going to go ahead and go across the top since I've got a common denominator now. This is going to be x plus, and then if I distribute this 1, it's not really going to change anything. So 1 minus 2x on the top. Now my common denominator is 1 minus 2x to the 3/2. And so in the very bottom here, since this does not have a denominator, it's just x minus 1, I'm going to put that over 1 and then take that and flip it and multiply. So right here I'm going to have times 1 over x minus 1. Now the only thing I have left to do is simplify what's in the top here and combine like terms. So when I do that, that's going to end up being a negative x minus 2x is negative x plus 1 over the 1 minus 2x to the 3/2 times 1 over x minus 1. And so then I'm going to go ahead and take out a GCF. Andrew, get the door. I'm going to take out a GCF in the top here. So that's a negative. So I'm going to get negative and then parentheses x minus 1. Then 1 minus 2x to the 3/2 times 1 over x minus 1. Alright, so then my x minus 1's are going to cancel out. Okay, so then I'm just going to be left with a negative 1 over this 1 minus 2x to the 3/2. But I'm not going to leave this 3/2 as a fraction like that. And we've kind of done this before. I'm going to take that and write it as a radical. The bottom number tells you what kind of root you have. So it's going to be a square root. And then 1 minus 2x to the third is going to stay, that 3 stays with the factor there. So this should be my final answer for that one. Alright, second one. So on this one, it's a little bit different than the last one because I have a negative exponent. And so any problem that you have with a negative exponent, you need to take that negative exponent and move it to the bottom to get rid of it. Now, when I say move it to the bottom, what I do not mean is move it to the bottom of this entire fraction right here. I do not mean move it to the bottom of the whole thing. You're only going to move it to the bottom of what it's being multiplied by. And so that's the x squared. So this is how my problem is going to look. Don't be lazy and not write this out again. So 4 minus x squared to the 1/2 plus x squared over, and then this is going to be 4 minus x squared to the positive 1/2 now that I have lowered it to the bottom. Now, that's going to go all over what was in the denominator, 4 minus x squared. Okay, so this is my new problem here. And so I need to get a common denominator with these two in the top here. So I'm going to go ahead and put, this is kind of like over 1 for now. And so to get a common denominator, I'm going to multiply the bottom and the top by the 4 minus x squared to the 1/2. So I'm going to give this a 4 minus x squared to the 1/2. Now, when I multiply these two things right here, okay, it's just like if I had this. let's say I've got x to the 5th times x to the 3rd. If I multiply those, I'm going to add the exponents to get x to the 8th. Okay, the base is the same here, so I just add the exponents. Same thing happens here. The 4 minus x squared, 4 minus x squared, the base is the same, and so I'm just going to add these exponents. So this is going to end up being 4 minus x squared to the 1, or to the first power, since 1/2 plus 1/2 is 1, and then plus x squared. And I can kind of just go ahead and drop these parentheses here, since it's just to the first power. So it's really like 4 minus x squared and then plus x squared. So that's what I have on top there. Now, on the bottom is just the common denominator, 4 minus x squared to the 1/2. And then I'm going to do the same thing I did on the last one and take that and flip it. So that's going to be multiplied by 1 over 4 minus x squared. Now, my negative x squared and positive x squared are going to cancel out, which leaves me with 4 on the top. Okay, so 4 on the top here, and then in the bottom, what you're going to do is when you multiply, you're multiplying these things in the bottom, you're going to add the exponents. So 1/2 plus 1, okay, or you can think of it as 2 halves. 1/2 plus 2 halves is 3 halves. So in the bottom, I'm going to have 4 minus x squared to the 3 halves. But remember, we don't want to leave this as a rational exponent. We want to write it as a radical. So I'm going to go ahead and make this the square root of 4 minus x squared to the 3rd. And that'll be my final answer. Alright, last problem. On this one, I think it's easier on these kind of problems to write this not with a radical, but like we had on this last one, where we had the 1/2 powers, because a radical is the same thing as a 1/2 power. So I think it's easiest to rewrite this problem as x plus 1 to the 1/2 minus 1 over 4 times x plus 1 to the 1/2, and then all over the x plus 1 to the 1/2. Alright, so then I'm going to get a common denominator. This fraction over here needs a 4, so I'm going to put a 4 in the top and the bottom, and it also needs an x plus 1 to the 1/2. Trace. Alright, so that Trace, stop it. Trace, you're going to mess my video up. I'm sorry to the people watching this video. Trace. Okay, so Andrew, get out of the picture. Okay, so then I'm going to go ahead and multiply across the top here. Alright, so when I do that, that's going to end up giving me I'm going to come down here and do it, a 4 times, now 1/2 plus 1/2 is just 1, so that's x plus 1 to the 1st, and then minus 1 on top. And so then on the bottom of that is just the common denominator. So this is going to be over 4 times x plus 1 to the 1/2, and then this I'm going to go ahead and take and flip. So times 1 over x plus 1 to the 1/2. Now, I need to go ahead and distribute across the top here so I can combine like terms. So that's just going to end up being 4x plus 4 minus 1. And so then I'm just going to go ahead and combine like terms here. So 4 minus 1 is 3. So 4x plus 3 over the 4 times x plus 1 to the 1/2 times 1 over x plus 1 to the 1/2. Please stop. Alright, so then in the bottom, I'm going to go ahead and just multiply straight across. Same thing with the top too, but the top is not going to change. It's just going to be 4x plus 3 since I'm multiplying by 1. And then in the bottom, 1/2, when I multiply these two things, 1/2 plus 1/2 are 1. And so I'm just going to be left with 4 times an x plus 1 to the 1st, which you can leave the answer like that. Or you can come over here and say 4x plus 3 over 4x plus 4. Either one of these are perfectly fine. I'd probably like this one where it's factored out. So either way is fine though.